So we actually discussed this slide, but I want to go back into it because there are some important details that are differences between Java and C. Again, just to refresh your mind, what I'm trying to do is, for whatever syntax we have in Java, I'm going to focus more on what is different, right? Because you guys now already experts in C, I hope so. So you know the syntax of the language. Java is very similar, but there are some differences, and these are the important ones that you need to learn. Again, the more you do programming, the more you'll realize that it doesn't really matter which language you are using, as far as you can get what are the differences of this language, what are the power of the language, why people even thought in getting Java rather than we already had C before, right? So if you know the differences, this is the important thing. Good. So double subscripted arrays. We already have 2D array C, right? The main difference in Java, the main difference we have is every row of the matrix, you can think of the 2D array of Java as a matrix, or even C. Okay? But the difference in Java is every row you can consider, I don't know, I'm feeling that the voice is going up and down. Is that true? Okay. So every row in the matrix is basically considered as a separate array. And you can access this array in Java. We didn't have this in C, right? We didn't have this capability in C. You were not able to do any particular operation in a certain row in a matrix. You have to do this yourself, right? There is no direct access to it. So the thing that you need to understand is that every row in Java, like in a 2D array, is considered an array on its own. You can do complete math operations, very normal array operations on that row, right? One example we have here is, this is the way you just initialize your array. It's very similar to what we had before. We know that if you have a 2D array that is named A, so A01 gives you the element at row 0, column 1, pretty similar to C. But the thing here is now, even if this is a 2D array, you can still access it using only a single index. This wasn't possible in C. What this gives you is the row number I in this matrix, right? So you can think of AI as the row I in this matrix, right? And as you can imagine, this is a row, so it's an array of its own, right? Because the 2D array is nothing other than an array of arrays, right? So this is one of these arrays that we have in our matrix. And then you can use the normal things we have seen in a single dimensional array, like ai.length will give you the size of the row I, right? And then if you want to refer to certain row, you can just use A0 is row 0, row 1, row 2, right? Want to get what? So now ai.length gives you the size of one row. What if I want to do operations on the whole array itself? If you just use A without any index, that means now you are referring to the full matrix. Then a.length, what does it mean to have a length of like a 2D array? This counts the number of rows, right? This doesn't give you the total number of elements, as you may imagine, right? The a.length gives you the total number of rows you have. Good? Then if you have, you can think of what I need, the total number of elements. What can I do in this case? How can I get the total number of elements I have in A now, using only information from this slide? Yeah. Yes, but this is the basic thing, but because AI, you have multiple AIs, right? So now a.length, as you said, gives you the number of rows, right? But I see what you are referring to. You are referring that maybe all the rows have the same dimension, and then if you just use any A0, A1, or A2, general AI, this gives you the number of columns you have in one row, which is equivalent to all the rows, and then multiplying both will give you the total number of elements. So that's correct. Please give me your name afterwards. Okay? So what your friend is saying is, I have number of rows, I have number of elements per row, which is ai.length, multiply both gives you the total number of elements. It's a very basic thing. Okay. But this is true for C, not for Java, right? It's still correct, but under the situation that we know, under our mindset from C, which is all rows have the same, as I was saying right now, all rows have the same number of columns, right? But in Java, given that you can think of, the mentality is that you can think of every row as a separate array, rows can have different number of elements. So now it's not a uniform 2D matrix, right? You can have a matrix that has, the first row has 2 elements, the second row has 3, the fourth row has 4, etc., 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 right? So why can I do this in Java? Because if you remember from our last lecture, arrays in Java are not just a normal array as in C. Array in Java is in fact an object, right? And then when you define a 2D array, this is an object of objects. But you can have an object of objects that if every one of them has different number of elements, right? If you remember from structures, right? Because this is what we know about objects so far. If you remember from C structure, you can have a structure and then you define some structures inside this. But every structure can has different number of elements. You can have a structure with 2 elements, 3 elements, 4 elements, right? You can take the same mindset, apply it to arrays in Java. The reason is array is just an object. So you can have the 2D matrix is an object of its own, has different number of objects, which is everyone is a row. But every row is an object of its own, array of its own, can have different number of elements. Good? So to answer, to have the correct answer for my previous question, is now it's not enough to just get the size of any row. What can I do then? Just one extra step. Yeah, do a for loop for every row and then count this, right? Take the total count, then you get the number of elements, right? Good? Okay. So just one example that shows here we have different number of elements per rows. The first row has 3 elements, the second row has 2, the third element has just 1 element. Good. So this is very similar to the array. You define an object in Java by using the new word. Remember that this new reserved word means allocating a place in memory, right? So you in programming language, you say this, now you are creating an object in the memory, right? So here, by just doing this, we said nothing is allocated in the memory, right? You cannot even access this. You can think of this as you just declare it, but no place is allocated right now in the memory, and you cannot access these elements. You need to use this to allocate the elements of the array, right, in the memory. So now you define this 3 rows by 2 columns to the array. So you can do this, but this gives you an array that only has the capabilities of a 2D array in C. All rows here have the same number of elements, right? Because you just say, I want a 2D matrix of 3 rows, 2 columns. So every row of the 3 rows has only 2 elements, right? What if I want to do the extra capability that we have in is each row has different number of elements. Now you cannot do this, right? You cannot define all the rows, or in Java language, you cannot define all the objects in just one statement. You need to do this in different statements, right? What you can say is first declare your array, and then you allocate the number of rows of that array. And then as you can imagine, the last step is to allocate each row separately, right? So you can say, now B0 is an array of 3 elements, B1 is an array of 2 elements, and B2 is an array of 1 element, something like that, right? Why I need to do this? Because now you need, for each row, you define different number of elements. Good? This makes sense? Yeah. Here? Yeah, so you can think now like it's the same thing. It doesn't really matter, right? But you see the point, right? Why we were able to do this? Because now, don't think of an array like what you have in mind as a 2D matrix. It's not. It's just an object that can have any number of elements. And a 2D array is nothing other than object that combines multiple objects. Every one of them has its own characteristic, right? You can even define 3D array, 4D array, n-dimensional array, it doesn't really matter. Because at the end, you instantiate objects in the memory, right? This makes sense? Good? Okay. So one example we have here is this one. I'm not going to explain it because my original plan was to explain this one and give you a little bit harder quiz. But then I said maybe I make it easier. So what I would do, given that this is our quiz in Java. So I'm going to leave this program as it is. What you are required to do is just trace it, implement it, just take the code as it is, like implement it in NetBeans or even the online compiler. And then, just 1 second, don't start now. Right? And then what you need to submit into Avenue is what is the output of the program. Here we are outputting something related to a 2D array, and the only thing that you're required to submit is what is the output of this array. Right? So for this, given that this is an easy task, I'll give you 5 minutes, and you can start now. This was the original quiz that I intended to give you, and I wish now I had given you this after you talking. But the thing that I'll try differently is maybe you try it on your own, good, honestly on your own, and then you just submit it. I'll create a folder for this. I will consider this as like a bonus mark, right? So just try it at home, consider it as like an additional example, an exercise. And what you can do is write this. You already had exactly the same quiz for C, so it's good also to see what you can do in Java. And I'll create a folder to submit this as a bonus mark. Good. You are not required to do so. If you don't want to wish it, like don't submit. Again, it's like a bonus, so it's up to you. Good. So the other thing we want to discuss today, and this is a valid thing in both in C and Java, but we didn't consider it in C. I mentioned it last time when I was discussing what you guys should do in labs. Your programs should be user-friendly. And I said one alternative is to accept inputs as an input argument to your main program, right? And we do this through taking inputs to the main. I guess we never had an example like this before, but let's see it in Java. Again, you can do the same thing exactly in C. It doesn't really matter. So this is called command line arguments, and you have to provide these arguments when you run the program. So once you create an executable, when you run the executable, you input the arguments or the parameters to the program to run through, right? And this is very useful. Like if you run any meaningful like actual program, you have to take some input from the user, right? So one example here is a very basic example that explains to you how these things work, right? In Java, again, the same thing applies in C, is you can take arguments as string from the screen or from the command line, and the way they are saved in an array, right? So argument 0, argument 1, argument 2. So you can even provide different number of arguments based on your program, right? So you may imagine that your program accepts 2 arguments, 3 arguments, 4 arguments, right? And a good programming, I'm going to use your program. How can I know how many arguments you need to take, right? Can you guys imagine what people usually do? When you execute a program, you should have a help that tells you, please provide 3 arguments. The first one is supposed to be the number of students. The second one is supposed to be like number of classes, something of that sort, right? So you provide a help message at the beginning of your program. This is how you should write your program. You have a program that the very beginning, the first thing you need to give to the user is how to run your program. And then the user will provide you an input, and then you take this input and process it to do something, right? This is ultimately what you should do for any program, even for your labs, good? So one example here is we take 3 inputs from the command line or from the screen. And the way you do this is after defining them, you say num1 integer.parseInt. You just read arg0. This is the array, again, that the input arguments are saved in, good? But they are saved as strings, right? In Java, it's very easy to process something, and we have seen this in print line and in reading something from the screen. By doing a parseInt function or method, you take this first argument and then you use it as an integer, you put it in num1. The same thing for num2, and then if you do the sum, you just add them up and then you give this to the user. Good? Again, these are the 3 steps that you should be doing, but one additional thing here is to tell the user, please input to, the way to run the program is to input to For example, integers as like arguments to the program. Good? This makes sense? Okay. So if you are using a GUI, the way to do this, I guess this is in NetBeans, is when you have your program, you just say the arguments are this and this, right? If you are just using Linux or a command line, when you compile your program, you have the executable. When you run it, you provide both inputs at the command line. Good? So now, today's lecture may be the first actual lecture about Java, the thing that we didn't have in C, right? Which is OOP, Object-Oriented Programming, and classes. Good? We already have seen some examples, but they will help us today understand what is the concept itself. Good? So you'll find that the first few slides don't have new information, but just puts everything in the context of OOP. Okay? So as we said before, every program in Java is just a class, right? Remember the very first example we had? We defined a class that we give it a name, and then main is the first method you have in this class, and it has to be public, right? Then you have two types of classes. The one that are already in Java library code, right? In the language itself, similar to the string class that you can use. And the ones that you define. You can define classes of your own, right? These ones that are already predefined, someone already defined them, put them in the library of the language. So there is no big difference between both, right? But you can use these directly. And if you want to define your own class, you can do so and then use it in another program, as we will see. Okay. A class is similar to structures. So I hope you guys remember what we have covered in structures, because the concept is exactly the same, but it's just extended, right? We said a structure is a data type of its own that you can define variables of this type, right? You remember we defined a class called monomial, and then we define different variables of monomial that we call monom1, monom2, monom3, etc. Right? So you define a new data type. And one clear example here is string data type is nothing other than a class in Java, right? Again, classes are generalization of structures in C. Okay. So one example class here that we call interval, it has two inputs. As you can see, this one, you can do exactly the same thing in C using structures, right? So with this very easy, like preliminary example, we didn't do much of using classes in Java, but it gives you the idea, right? So imagine this as just a structure in C, and it has two elements. One is called left bound and one that is called right bound. This is just define an interval of real number, right? So the way you define the class is you use this specifier. Here it's public because any other class can use it. The reserved word class tells us this is a class similar to structure in C struct. And then this is the class name, interval. These are the elements of the class, and here you end it, right? One of the most important concepts of OOP is a class and an object, right? A data type and an instance of this data type. Okay? So by defining this class, now you are defining a new data type that we call interval. Okay? Later you can say interval, int1, int2, int3, like xyz, any name, any valid variable name in Java, and it will be an object of this class, right? What does an object mean? You can think of this as a clone of the data type itself. Similar to when you define an int x. X is an integer variable, the characteristics of an int type, right? Same thing. By defining an interval, and then you define int1 as an instance or an object of interval, it's going to get all the characteristics of interval. For example, it will get two elements. One is called left bound and right bound, right? So let's just jump through an example. Here it just tells you what you need to do to include a class in your program using the GUI. I'll just leave this for you. We already covered this. We need to find an example here. So to create an example, come on. Yeah. You just write this as int x, interval int1, right? Int1 is going to be of type interval, and you can later say this is to allocate the memory. int1 equal new interval. Again, new is very critical because here you just declare an instance or an object of the class, but you didn't allocate anything in memory. We started our lecture today by this, right, for arrays. You have to use the new word and then to allocate a place in memory for the int1 variable. And as you can imagine, this new place will have enough space for all the elements of interval, right? Interval had 2 members, both are double, so you are going to reserve in a memory 2 locations, each one of them is double. So 64-bit and 64-bit. Okay? Okay. And then using the dot operator, similar to what we had in structures before, you can say int1.left bound. Here int1 has all the members of interval, so it has left bound and right bound, right? Any questions so far? Good. So here the thing is, we declare this class as public, which is if you want this class to be used in any other class in the project. Right? So you can define a completely different class that you call, I don't know, my interval, or you call it math operations or something, and then you want to use the interval class inside this class. You cannot do this without having the original class as public, right? And we will cover this more later because it's one of the most important concepts in Java and in OOB in general. Good. So here we define a new class. Assume that we already have like a different class that has a method that we call test interval, right? Inside this test interval method, which is not in the interval class, it's in a different class, we define an instance of interval, and then we assign some values, and then we print, like we do the normal operations of that, like assigning variables, print it, read something from the screen, assign it to it. You can modify, read or write. Good. Why we can do this? Because again, interval is a public class that you can use this in any other method in any other class. Good. If we define interval as private, for example, you cannot use interval inside test interval if test interval is in another class. Good. So we will see this later in more details, as I said, but for now you need to understand this concept. It's what we call encapsulation in OOB, which means now you define your own class. Remember the example that we started with, maybe you build a system for your university. So you have a class that is called student, another one that is called, I don't know, instructor, another one that's called courses, for example, right? These are separate classes, like separate entities that no one has, like for example, a student class doesn't have access to the courses class unless you define the courses class as public, for example. Good? And then even when you define the courses class as public, maybe inside the courses class itself, some variables will be private and some will be public. So the students class cannot use the private elements of the public courses class. This is called encapsulation, and can someone say why this is important? Why we may need such encapsulation or abstraction in OOB? Can someone imagine why this may be useful? Yeah, protect data. Security is the main reason, right? You want them to interact between each other, but you don't want to be able to change any part of the code. For example, you as a student, if you have access to the course's grades, you can just go ahead and like get yourself all A's, right? So you don't want to do this. What you want to do is you should be able to read your grades, but you will not be able to modify it, right? So the way you should program this in your database is you have like a certain access or authority, authentication to certain actions and events inside one class, but you cannot modify it, for example, right? It's called encapsulation in OOB, and it's very important. Right? And we'll talk about this like in more details later. Good. Here, the complete example of using our interval class. We define a new class that we call test interval, and then what we do is we instantiate a variable or an instance or an object of interval, new interval, and then we print its original values, right, which may be zeros, and then we assign variables to left and right, like we assign values to left bound and right bound variables, like 2.3, 5.6, and then we print them again. When you print them, what you should expect assume the value was initially like left bound, right bound was initially 0, right? So what you should get here, 0 and 0, right? But then you modify them. What you should get here? Yeah, 2.3 and 5.6, right? Right? So why you say 2 and 5? These are not integers, right? These are still int1. Maybe the naming is confusing, but n1 is just the name of the class, right? You can call it anything. You can call it xyz, right? It has nothing to do with the integers at all. Good. And then you get the actual values of this thing. Good. One question for you is, what if I define another instance of interval class that I called n2, right? And then here I'm trying to print, instead of int1, n2 left and right. What should I get? So again, I define two instances of interval int1 and int2. I printed int1 members, I modified them, but then I print int2 members. What should I get here? Yeah? Zeros, right? The reason is these are completely two different objects of the same class, yes, but they have different elements. So in the memory, so it's very important to understand this. So by defining this thing here, you allocate a separate place in memory for int1, right? This is int1, and this has the left and right bound. Okay? If I define another one that I call int2, you allocate a separate place in the memory that has both left and right. These two are completely separate than these two. Yes, both int1 and int2 have the same type, but this is similar to say you define int x and int y, but x can has a different value than y, right? So you instantiate different instances of the same object means you allocate different places in the memory for each object. If you modify one, so what we have done here is modified n1. If you print n2, you just print these values, not these values, right? This makes sense? Okay. This is already captured, and this is what we have been covering about encapsulation and information hiding, right? So if for this same example, if we previously defined our interval class as private, if I try to run this one, I'm going to get a syntax error. It's not going to compile. The reason is you are trying to access a class that is not defined within this block of code, right? Sense? Okay. So one example of trying to encapsulate data is to make the class itself as private, as I said. But what is the problem with this? If I made a class as private, like this interval class, make it private, this code will not work. What is the problem with this one? You cannot use it, right? You cannot use it in other classes. Good? That means the class is not usable. So maybe we need another level of control, like a finer grain control over the class. Not the whole class should be private, but some important data should be private and the other things should be public. Which means other classes can still access this class, but cannot do certain things. So you provide them certain authority or certain authentication to do certain things inside the class, right? But they have access to it. Good? Make sense? So how can we achieve this thing is when we come to our original class here, maybe just one example would be if I define this as public, but made the left bound as private and right bound as public. What would happen? As a test interval class, I will not be able to assign a value for the left bound, but I'll be able to assign a value to the right bound. Right? Make sense? Good? Okay. Good. So I already told you about this. If we make both private, then we'll not be even able to access any of them. So Again, the same problem exists here, is if we define these two as private, I'll not be able to write, but even I'll not be able to read. So they are not beneficial to me. What people or what good programmers usually do is, instead of doing that, they define these two as private, but they define public functions to give access to these variables. What does that mean? So what you want to do, you want to do something like this. So assume this is my interval class. This is going to take 1 minute, but it's very, very important, right? Like this is the main concept of why even people had OOP, okay? So this is my original interval class, okay? This is another class that is maybe test interval. Here I have some private data. No one is able to access this private data, good? You as a class or a programmer is to provide some API here, some interface that other classes are able to access, and this interface is the one that interacts with this protected data. Good? So now you control, it's like you define a gate or a door to the protected data in your class. Good? Now it's like you are an interface between your original protected data inside your class and the outsiders. Any outsider want to access something, comes to you, and you provide him with only the data that you allow it to provide. Good? So next lecture we will start by seeing how this actually works in code. Good? Thank you.
Going through your YouTube videos lately.
Yeah.
That's really helpful.
Yeah, thank you. That's good.
But the question I had was for Java. So we